Hello everyone. So today we are going to solve the Maths B of January 2020 paper 2. Let's start. Question number 1. A is equals to 2 to the power cube into 3 square into 5 into 7. B is equals to 2 into 3 to the power 4 into 5 square into 11. Find the highest common factor of A and B. So we need to find the HCF of both A and B. Let's start. So in order to find the HCF, I will first write each element of A and B individually. That is, I will write 2 3 times because it has 2 cube. So 2 into 2 into 2, and 3 2 times because it has 3 square, and a single 5 and 7. I will repeat the same thing for B, writing 2 1 times and writing 3 4 times, and then 2 5 and 1 11. We can see now we need to just pick out the numbers that are common between both A and B. We can see that this 2 is common between both A and B, this 3, and this 5. So these are the numbers that are common between both A and B. So we can write HCF as 2 into 3 into 3 into 5, and if we multiply 2 into 3 into 3 into 5, we get a value of 90. So the HCF of both A and B is 90. Part A is done. Moving to part B, find the lowest common multiple LCM of A and B. So now we need to find the LCM of both A and B. For LCM, we just need to select the number that has the highest power between A and B. Like we can see that both A and B has 2, but the value of 2 for A is higher than the value of 2 in B because it has 2 cube, because A has 2 cube and B has only a single 2. So we are going to choose this 2 cube. For LCM, I'm doing the same thing, that is choosing the number that is common between both with highest power. That is 3 to the power 4. I'm choosing 3 to the power 4 for LCM. Choosing 5 square for LCM, and as 5, 7 and 11 are not common between each other, so I'm going to choose both of them. And these are the numbers that will be inside the LCM. So now the LCM would be 2 to the power 3 into 3 to the power 4 into 5 square into 7 into 11. And if you calculate all this, you will get a value of 1247400. This is the value, the LCM of A and B. So part B is also done. Moving to part C, find the least number that A must be multiplied to give a square number. So in order to find what number we need to multiply so that the result of A is eventually a square number itself, we need to make every element of A a square itself. Like we can see that elements of A contain 2 cube into 3 square into 5 and into 7. So these are the 4 elements inside A, and we can see that 3 is already itself a square, so we need to make 2 cube a square or 5 a square and 7 a square. In order to do that, we need to multiply another 5, so this to 5 makes a 5 square, another 7, so that this to 7 makes a 7 square, and if we multiply 2 another 2, then it would be this 2 cube and this 2 would make a 2 to the power 4, and we can obviously write 2 to the power 4 as 2 square into 2 square. So now we need to just multiply 5 into 7 into 2, and this would look like 2 square into 2 square into 3 square into 5 square into 7 square, and the result is a square number. So what we did to get this square number, we just multiplied an extra 5 7 and 2. So the number that we need to multiply to A so that the result is a square number is 5 7 and 2, and if you multiply 5 into 7 into 2, you get 70. So we need to multiply 70 to A. We need to multiply 70 to A to make it a square number. part C is done. Part D, work out the value of C, giving your answer as a number in standard form. So this is the value for C, 3 into 10 to the power 205 into 5 into 10 to the power 205. And we now need to simplify this and leave our answer in a standard form. So let's start solving part D. C is equals to 3 into 10 to the power 205 into 5 to the power 10, 5 into 10 to the power 205. At first we can multiply the numbers together, like that is 3 and 5. 3 into 5 is 15, and now we are gonna add the powers of 10 together. That would be 205 plus 205. And this would look like 15 into 10 to the power 410. So this is the answer of C in standard form, that is 15 into 410. I hope question number 1 was clear. Moving to question number 2. The points with coordinates 2, 1, 5, 1, 3, 3 and 6, 3 are the vertices of parallelogram A. On the grid, draw and label parallelogram A. So the points of the parallelogram A are already given. We just need to draw this, plot this on the diagram, on the graph. So let's start. The plots were 2, 1, 2, 1, 5, 1, 3, 3 and 6, 3. Okay, so 2 1s means 2 on the x-axis and 1 on the y-axis. So there would be a point over here and a 5 1, so a point over here. Another point was 3 3 and 6 3. So these are the 4 vertices of the parallelogram A. We need to connect the dots, and that's done. Part A is done. This is the diagram, or the diagram for part A on the grid. Part A is done. Parallelogram A is transformed to parallelogram B under the translation 2 minus 5. On the grid, draw and label parallelogram B. So as the question have used the word translation, we know always that whenever the question uses translation, we need to use a certain formula. The formula is V is equals to I minus O. V is vector, I is image, and O is object. So we need to subtract the object from image in order to find the translation vector. The translation vector is this one. The translation vector is already given. Here the object would be parallelogram A, because it came first, so this would be the object, and parallelogram B would be the image. And as we have to find the vertices or the point for image, now we need to rearrange the equation and make I the subject of it. So let's solve it. V is equals to I minus O, but as we need to make I the subject, because we need to find the value for image, so the equation would be now like vector plus object. The value for image is not given, the value for vector is given, and object is also given. Vector is 2 minus 5, 2 minus 5, 2 minus 5, 2 minus 5, plus 2 1, 5 1, 3 3 and 6 3. So I repeated the vector 4 times because we need to add this vector to all the 4 vertices of A in order to find the vertices of parallelogram B. That's why I repeated the vector 4 times. It's not necessary to write a vector 4 times. You can just calculate it and you can write just one vector here only. That will be fine too. So if you add 2 plus 2 is 4. Then it would be negative 4 at the end, at the base, and 7 and 5 and 8 and negative 4, negative 2 and negative 2. Yes, so these are the coordinates of parallelogram B. Parallelogram B. Now parallelogram B is done, and now we need to draw this on the grid also, because the question asked you not to find the vertices only. We need to draw this on the grid too. So let's draw this. The vertices were 4 minus 4. So one point would be over here. 7 and negative 4. Another point over here, 5 negative 2 and 8 negative 2. So join the lines and the parallelogram B is done. So this is the parallelogram B. Moving to part C, parallelogram B is transformed to parallelogram C by a reflection in the line with equation x equals to 2. So when under the line x equals to 2, there is a reflection of parallelogram B that transformed it into parallelogram C. So it did. Now for this case, C is the image and B is the object. So let's draw this again. The line of reflection was x equals to 2. So that means the line of reflection was around this line, exactly on the vertical line on point x, on point 2. And now we need to reflect the parallelogram B onto parallelogram C. We can see that this point is 3 units away from the line, away from the reflection line. So the image of this point would also be 3 units away from the original line. So it would be on this point. We can see that this point is 1, 2, 3, 4, 5, 6 units away from the line, reflection line. So the image also would be 3 points, 3 units away from the reflection line. So 1, 2, 3, 4, 5, 6. It would be around this point. This point is 2 units away from the reflection line, so it would be on this area, and this point is 5 units away from the reflection line. So this image will also be 5 units away. 1, 2, 3, 4, 5. So around this place. So these are the 4 vertices of the parallelogram C. We need to connect the dots to give it a structure. This is parallelogram C. Done. And there is no need to draw or keep that line of reflection in your diagram. You can totally remove it if you want to. Let me write it. This was x equals to 2 reflection lines. So now part C is also done. Moving to part D. Parallelogram C is transformed to parallelogram D by a rotation through 90-degree anti-clockwise about the point with center -50. On the grid, draw and label parallelogram D. Now the trick over here is that we can obviously draw the parallelogram D over here by using a protector and by using line of construction. No, we can't use a line of construction for this, but we can actually draw the parallelogram D by using a protector. What we need to do is extrapolate these lines to -5 and 0. This is the center of the rotation. So extrapolate these lines to this point, connect the lines together, and then using a protector, draw exactly a point that is 90-degree from this line. So the image would be somewhere around -3 and 4. So that's actually tough to show in this electric device. So I am gonna do a math for this to make it much more clear that you can actually find the coordinates of a image that is actually rotated 90-degree. So, and using a mathematical way. So I'm going to use a mathematical way. So as it's given that the center of origin, that the center of rotation was not the origin, it was actually -5 and 0. So we now need to find the distance of the object from the origin. We need to find the distance of the object from the origin. That is basically the coordinates of object from center -5, 0. So at first we are now doing part D, and we have to find the coordinates of object from center 5, -5 and 0. Here the coordinates of the objects will be the coordinates of parallelogram C, So we need to subtract the center from the coordinates of parallelogram C. The coordinates were -1, -2, 0, -4, -4, -2, -3, -4. And now we need to subtract the center. The center was -5 and 0. I'm going to repeat the center 4 times again because we need to subtract the center from each vertices of parallelogram C. So I'm repeating it 4 times. And if you subtract -5 from -1, you will get a value of 4, 5, 1, 2, -2, -4, -2, -4. So these are the coordinates of the object from the center -5 and 0. And now we need to multiply the matrix of 90-degree anticlockwise to this new coordinate to find the coordinate of the image from the center -5 and 0. So now we are finding the coordinate of the image from center 0, 0. Sorry, from center -5 and 0. So the coordinate we will get after this calculation would actually be the distance from the center -5 and 0. So now we need to multiply the coordinate we get from this part. We got from this part, that is -4, -2, 5, -4, 1, -2, 2, -4. So 4, -2, 1, 4, -2, 5, -1. It was 5, -4, 1, -2, and 2, -4. And we need to multiply the matrix. The matrix was 0, -1, 1, 0. And we will do this by using the method first row and first column. So if we multiply first row and first column, you will get a value of 2, and then first row second column, so that would be 4. For first row third column, that would be 2. First row fourth column, that is 4. And now we need to multiply the second row first column, that would be 4, 5, 1, 2. Now these are the coordinates of the image. Image was parallelogram D, but the fault is that this is not from the origin 0, 0. This is the coordinates from the center -5 and 0, and we cannot draw this on the diagram because whenever we draw anything on the diagram, its axis or coordinates are always from the center 0, 0. So now we need to make or find the coordinates of the parallelogram D from center 0, 0. And in order to do that, we need to add this center again so that we can get a value of the coordinates of the vertices of parallelogram D from center 0, 0. So now we are calculating for the coordinates of image from center 0, 0. And how we will do that? We will just add the center -5 and 0 to this coordinate of image we got from this point. So 4, 5, 1, 2, 1, 4, 2, plus -5, 0, -5, 0, -5, 0, -5, 0. And if you add these two together, you will get a value of -3, 4, -1, 5, -3, 1, -1, 2. So these are the coordinates of parallelogram D that we can actually draw on the grid. So let's draw this. This was -3, 4. So -3 and 4 would be around here. -1, 5. -1 and 5. So it would be over here. -3, 1. This thing over here, and -1 and 2. So these are the 4 vertices of parallelogram D. We need to connect the dots together. And parallelogram D is drawn. And with this, our question number 2 ends. I hope question number 2 was clear. Moving to question number 3. In figure 1, A and B are 2 points on a circle with center O. The line AC is the tangent to the circle at A and OBC is a straight line. AC is 15 centimeters and angle OCA is 25 degrees. Calculate the area in centimeters square to 3 significant figures of this circle. So we need to find the area of this circle, but we can see that the radius is not given. So we need to find the radius first. And how can we do that? We can see that OA is actually the radius of the circle, because OA is the center and A is at the circumference, and the center connected to the circumference is actually the radius. So we can find the radius of the circle first using the Pythagoras theorem. So now we are using the idea. Let me draw find the radius over here. Now we are using in triangle OAC, and not the Pythagoras theorem, we can find the sine cos tan formula. We can see that when OA is opposite of 25 degree and AC is the adjacent of the 25 degree, that means we need to use the tan. So in order to find the length of AB would be tan 25 degrees into 15. And if you calculate it, you will get a value of 6.9946 centimeters. 6.9946 centimeters. So this is the value for the radius of the circle OAB. Yes, so of the circle OAB. So let's now write the formula for the circle. Area of circle is pi r square. And we just found the area of the radius, that was 6.9946. So 6.9946 whole square. And if you calculate it, you will get a value of 153.7 centimeters square. But our question asked you to give your answer to 3 significant figures. So I will round up my answer to 3 significant figures. That would be 154 centimeters square. So this is the end of part A. Moving to part B. The region inside the triangle OAC but outside the circle is shown shaded in figure 1. Calculate the area to 2 centimeters square, in centimeters square to 3 significant figures of this shaded area. So now we need to find the area of this shaded part of the triangle OAC. At first, I will find the angle of AOB. And we can find it by using the sum of a triangle method. So part B, and we are still in triangle OAC, and now I'm finding the area of angle of the AOB. AOC, let's write AOC, and that would be 180 degrees minus 90 minus 25, and the reason is sum of a triangle. And if you subtract these two angles from 180 degree, you will get a value of 65 degrees. 65 degrees. So the value of the angle AOC is 65 degrees. Now using this angle, we can find the area of the sector OAB. So let's find the area of the sector. Area of sector AOB. And the formula for this is theta by 360 into pi r square. For sector AOB, theta is 65 degrees. 360 is already given. 360 degrees into pi. Radius was 6.9946 square. And if you calculate it, you will get a value of 27.75 centimeters square. So the area of the sector is this, and we can find the area of the triangle OAC using the height, that is OA, and the base that is AC. And then we can get the value of the area of the triangle OAC. So let's start it over here. Area of triangle OAC is half into base into height. Base was 6.9946 into height was 15, and if you calculate it, you will get a value of 52.4595 centimeters square, and the area of the shaded region, we can find the area of the shaded region by subtracting the area of the sector from the area of the triangle OAC. So area of triangle OAC minus area of sector AOB. Area of triangle was 52.4595 and area of sector is 27.75, and if you calculate it, you get a value of 24.7095 centimeters square, and the value is 24.7 centimeters square. I round up my value to 3 significant figures because the question asked us to do so. So that's why the answer is 24.7 centimeters square. And this is the end of question number 3 also. I hope question number 3 was clear. Moving to question number 4. In a race, Akash ran a distance of 8x square minus 105 meters in 6x plus 1 seconds. His average speed for the race was x meter per second. Show that x satisfies the equation 2x square minus x minus 105 is equals to 0. So here the distance is x square minus 105. The time taken to cover this distance was 6x plus 1 and the speed was x. And now we are using the usual formula for speed, that is speed is equals to distance over time. The value of speed is x. Distance is 8x square negative 105 divided by 6x plus 1. Now I am moving the denominator to the left hand side and then it would be multiplied to x. So x into 6x plus 1 is equals to 8x square negative 105, and if you multiply on the left hand side you will get a value of 6x square plus x. Shifting everything to the left hand side, or no, shifting everything to the right hand side. Let's just complete this line first, and now I will shift everything to the right hand side. So on the left hand side it would be 0 and 8x square minus 6x square minus x minus 105. I'm inverting the equation because whenever I try to find anything, the value for any alphabet, I always put that on the left hand side. So I will just invert the equation, and it would be 2x square, because if you subtract 6 from 8 you'll get a value of 2, negative x negative 105 is equals to 0. And this is what the question asked you to show. So the part A is done, and as you have already shown, we need to write as shown over here in the bracket. So part A is done. Moving to part B, hence calculate the distance in meters that Akash ran in the race. Show clear algebraic workings. So we need to find the distance that Akash ran. So here at first we need to factorize these equations that we got in part A to find the value of x. 2x square negative x negative 105 is equals to 0. Now we need to split the negative x into 2. So it would be 2x square negative 14x negative 15x positive 14 actually, and negative 105 is equals to 0. If we take 2x common, and it would be x plus 7, and if we take negative 15 common, it would be x plus 7 is equals to 0, and the two equations are x minus 15 and x plus 7 is equals to 0. And if you and then the value of x you will get is x is equals to negative 7 or x is equals to 15 by 2, that is actually 7.5. So these are the two values of x, and now we need to find the value of distance that Akash ran using two values of x. So the equation for distance was 8x square plus the equation for distance was 8x square minus 105. So distance is 8x square negative 105. I'm first going to use the value of negative x, so it would be 8 negative x square negative 105, and if you calculate it you will get a value of 287 meters. And using the other equation, 8x square negative 105 x 7.5 square minus 105, and if you calculate this you will get a value of 345 meters. So the two values of distance that Akash ran was 287 meters and 345 meters. Question number 4 is also done. I hope it was clear. Moving to question number 5. Question number 5. When Joe goes to school in winter, the probability that he wears a coat is 5 by 8. If he wears a coat, the probability that he wears a scarf is 1 by 4. If he does not wear a scarf, the probability that he wears a if he does not wear a coat, the probability that he wears a scarf is 1 by 6. Complete the probability tree diagram. So we need to complete it. It's already given that if it's winter and he wears a coat, the probability would be 5 by 7, 5 by 8. So 5 by 8 on this place. And the probability for not wearing a coat would be 1 minus 5 by 8. And that would be 3 by 8. So 3 by 8 on this place. And the probability for if he wears a coat, he will wear a scarf, the probability for this is 1 by 4. This was given. And the probability for not wearing a scarf would be 1 minus 1 by 4, and it would be 3 by 4. The probability for if he does not wear a coat and wears a scarf was 1 by 6. So the probability for not wearing a scarf here would be 1 minus 1 by 6 is 5 by 6. So part A is done. The tree diagram is already complete. Moving to part B. On a day Joe goes to school in winter, calculate the probability that part B, he is not wearing a coat and he is not wearing a scarf. So in part B, we have to find the probability that he is not wearing both. He's not wearing coat or scarf. He's not wearing anything. So we can see we need to choose this value and this value, because this value corresponds to not wearing a coat and this value corresponds to not wearing a scarf. So part B, probability no coat and no scarf. The and means that we need to multiply to the two probabilities together. The two probabilities were 3 by 8 and 5 by 6. We need to multiply them and you will get a value of 5 by 16. So this is the probability that he was not wearing a coat and a scarf and no scarf. So moving to part C, he is wearing a coat or he is wearing a scarf, but he is not wearing both a coat and a scarf. So here we can see that the equation actually said that he was wearing a coat or he was wearing a scarf. There is a or over here and there is a but rule over here that he is not wearing a coat, both a coat or and a scarf. I will use a much easier way. So the easier way is, at first I will find the probability that if he was wearing both coat and if he was not wearing both scarf. So at first, solving part C, probability he was wearing both, or he was not we, there's supposed to be he, or he was not wearing both. So for the probability that he was wearing both, we need to select 5 by 8 and 1 by 4, both coat and scarf. So 5 by 8 and 1 by 4, and add it with the probability that he was not wearing a coat or a scarf. So that would be 3 by 8 into 5 by 6. And if you multiply this, you will get a value of 5 by 8 into 1 by 4 plus 3 by 8 into 1 by 4. The value is 1 by 4. Maybe there's something wrong. Let me do that again. 5 by 8 into 1 by 4 plus 3 by 8 into 5 by 6, and the value is 15 by 32. The value is 15 by 32. And now this is not exactly what the question asked us to do. The question asked us to do that if he was wearing a scarf or a coat, but he was not wearing both scarf or coat. So probability he was wearing a coat or scarf but not wearing both. And we can easily find this by subtracting this from 1. So 1 minus 15 by 32 is actually 17 by 32. So this is the end of part C. I hope part C was clear. Moving to part D. On a day Joe goes to school in winter, if he is wearing a coat and a scarf, then the probability that he is also wearing a hat is 3 by 5. Calculate the probability that on a day Joe goes to school in winter, he is not wearing all three of a coat, scarf and a hat. So at first I will find the probability if he was wearing all three. Part D, probability if he was wearing all three, that is scarf, hat and coat. The probability of wearing a coat was 5 by 8, the probability of wearing a scarf was 1 by 4, and the probability of wearing a hat was 3 by 5. So we need to multiply 5 by 8 into 1 by 4 into 3 by 5, and we get a value of, let me multiply first, 5 by 8 into 1 by 4 into 3 by 5, 5 by 8 into 1 by 4 into 3 by 5, and we get a value of 3 over 32. And now we need to find the probability that if he was not wearing all three. Probability if he wasn't wearing all three. And now we can find that by subtracting this 3 by 32 from 1. So 1 minus 3 by 32. And we get a value of 29 over 32. And this is the end of question number 5. We did found the probability that if he was not wearing all the three items. So that's the end. I hope question number 5 was clear. Moving to question number 6. f and g are two functions such that fx is equals to x square plus x minus 6, gx is equals to 2x minus 24 divided by 2 minus 2x. Find the value of x that must be excluded from any domain of G. So in order to find the value of x that must be excluded from any domain of G, we first need to make the denominator 0. We first need to know at what value of x the denominator of G is 0. So in order to do that, let's try solving. Start solving. Gx is equals to 2x minus 24, 3 minus 2x. Yes, 2x minus 24, 3 minus 2x. As I've already said that I need to first make the denominator 0 and I need to find the value for x that actually makes the denominator 0. We can see that if x, the value of x was 3 by 2, the denominator would be 0. So I am using the value of x is equals to 3 by 2 and it would be 3 by 2 into 2 minus 24 divided by 3 minus 2 into 3 by 2. We can see that this 2 and this 2 cancels out with each other and this 2 and this 2 cancels out with each other. We are left with 3 minus 24 divided by 3 minus 3. 3 minus 24 is negative 21, and if you subtract 3 from 3, we'll get a 0 at the base, at the denominator, and we know anything divided by 0 is infinity. And so the equation, thus we have proved that we need to exclude x is equals to 3 by 2 from the domain of gx. That must be excluded. So x can never be equals to 3 by 2. X can never be equals to 3 by 2. Part A is done. Moving to part B. Find the value of A and the value of B such that fx is equals to x plus A whole square plus B. So we need to make this quadratic equation. We need to just make quadratic equation. Solve this quadratic equation using the completing the square method. So completing the square method, the equation was x square plus x minus 6. Let's do this on the next page. Part B, fx is equals to x square plus x negative 6. And as we need to make solve this using the completing the square method, at first I will treat x square as x whole square, saying that the value for A was x plus 2x1. I am using the value for B as 1 because here the x doesn't have anything, it's with itself. So that means, the value for x would be half. As it doesn't have anything with x, that means something was added to the 2 that must have excluded this value. So in order to exclude the value for 2, we need to multiply half with it. And we know half multiplied 2 is 1. So as we have multiplied, we have taken half as B. So now plus half square negative half square negative 6. Now the thing would be x plus half whole square, and negative half minus negative 6 is actually negative 0.5. 0.5 whole square negative 6 is actually 25 by 4. Negative 25 by 4. So we can see that the value for B is negative 25.4 and A is half. So A is half and B is negative 25 by 4. Part B is done. Moving to part C. Hence write down the range of fx. Okay, we all know that this point is this is the point that this is the value for the y-intercept, and as we can see that this is a positive square graph, positive square quadratic graph. That means the shape of this graph would be a smiley graph. And this is the least point that would cross the x-axis, that when the curve will cross the x-axis, and the least point would be the value of B. So we can say that the range would be greater than and equals to b. The range for y would be greater than and equals to b. So part C, I've already explained, that would be y, not y, the equation was fx, so fx greater than equals to negative 25/4. Question number C is done. Moving to question number D. Find the value of C for which G inverse 0 is equals to C. So at first we need to find the value of G inverse. I always, in order to find the inverse of any function, I always think the inverse as y. So let gx be y and write the equation for gx. So y is equals to 2x minus 24 divided by 3 minus 2x. If we take the denominator to the left hand side, it would be 3y minus 2xy is equals to 2x minus 24. And if we shift every x to the right hand side and every number to the left hand side, it would be 3y plus 24 and 2x plus 2xy. I am now inverting the equation. That would be 2x plus 2xy is equals to 3y plus 24. And now I am taking just x common, just x common from the left hand side. That would be 2 plus 2y is equals to 3y plus 24. And if we take x common, this would be 3y plus 24 divided by 2 plus 2y. Now this is how the inverse equation is looking, but now we again need to write this at the other range, that G inverse is to x would give a value of 3x plus 24 divided by 2 plus 2x. What I did is just replace the positions of y with x, and this is the inverse of gx. Well, the equation was not like this. The equation was G inverse 0 is equals to C. So, not gonna write this like this. Let's continue the equation from this part. G inverse 0 means we have to use the value for x as 0. So, 3 into 0 plus 24 is equals to C divided by 2 plus 2 into 0 is equals to C. We know that if anything multiplied to 0 would be 0 eventually. So this would be 24 divided by 2 is equals to C. 24 and we get 12. So the value for C would be 12. Part D is done. Moving to part E. Given that fx is equals to gx, show this equation comes, okay, and show clear algebraic working. So we need to just put the equations together. We are solving E now. Fx is equals to gx. The equation for fx was actually x square plus x negative 6 is equals to 2x negative 24 divided by 3 minus 2x. And now if we take the denominator to the left hand side, this would be x square plus x negative 6 and 3 minus 2x is equals to 2x negative 24. And if you add the multiply these things together, that is 3x square negative 2x, 3x square negative 2x cube positive 3x negative 2x square positive negative 18 and positive 12x is equals to 2x minus 24. And if you simplify these things together, like we got a 3x square and 2x square, negative 2x square, we get a value for this is just x square. And then if you further simplify it, we get, oh sorry, I forgot to say that it has already a negative 2x cube, so then it would be a positive x square, and 3x and positive 12x is actually 15x, so positive 15x, and we have negative 18 over here and 2x and negative 24 over there. So now I will take everything to the right hand side, so the left hand side would be 0 and 2x cube negative x square. This 15 would be negative and this is a plus 2x, so the thing would be negative 13x. Negative 24 plus 18 is actually negative 6, so negative 6. I am inverting the equation, so it will be 2x cube minus x square minus 13x minus 6 is equals to 0. And this is the equation that the question asked you to do, asked you to show. So the shown part is done. So part G is complete. Moving to part F. Use the factor theorem to show that 2x plus 1 is a factor of this equation. So let's start. Part F, 2x plus 1 is equals to 0, and therefore the value of x would be negative half. As it was said that this was actually we have to show that this value of x is actually a root of this equation. So now we need to put this value inside this equation. So let's start. 2 negative half cube minus negative half square minus 13 negative half negative 6. And if you add calculate all this, you will eventually get a value that is 0. And as you have shown that for this value of x, the equation actually sums up to be 0, we can already see that this is actually the root of the equation. So it's shown that this was actually the root of this equation. Part F is also done. Moving to part G. The curve with equation y is equals to fx intersects the curve with equation y is equals to gx at the point A with coordinates p and q, where p is greater than negative half. Find the coordinates of A. So we can see that the equation for the point A would be this equation, because it's already given that fx is equals to y is equals to fx and y is equals to gx, and these two curves intersect, or these two curves intersect with each other. As they are intersecting with each other, we can already say that the equation for fx must be equal to the equation of gx for the point A. And we have already found a simplified equation for these two equations, that is 2x cube minus x square minus 13x minus 6 is equals to 0. So we just now need to factorize it. So let's factorize it. Let me see if we have another page. Yes, let's factorize it over here. G, we need to factorize 2x cube negative x square negative 13x negative 6 is equals to 0. So 2x cube, we will split the x square and 13x, and I'm splitting the x square as positive 4x square negative x square. I'm splitting the 13 as negative 10x, negative 3x, negative 6 is equals to 0. So the thing would be, if we take 2x square common, it is x plus 2. If we take negative x common, it would be x plus, sorry, this was actually 5x. If we take negative 5x common, it would be x plus 2. And if we take 3 common, negative 3 common, it would be x plus 2 is equals to 0. And our equation is 2x square negative 5x negative 3 x plus 2 is equals to 0. And now we need to further factorize x square minus 5x minus 3. So I'm going to split the negative 5x into negative 6x negative x negative 3. This would be a plus. And x plus 2 is equals to 0. So 2x, if you take 2x common, that is x minus 3, and if you take plus 1 common, it would be x minus 3, and x plus 2 is equals to 0. So 2x plus 1 and x minus 3 and x plus 2 is equals to 0. So we can see that the values of x would be negative half, x equals to 3, and x is equals to negative 2. But in our question, it was already given the value for p was greater than negative half. So we cannot choose the value x equals to negative 2 and x equals to negative half, because these are outside the range. The only answer for x that is inside the range is x is equals to 3. So now using the value for x as 3, we can find the y coordinate of point A. And the equation for this was y is equals to 2x cube minus x square minus 13x minus 6. Putting the value inside this, that is 3 cube minus 3 square minus 13, 3 minus 6. And if you calculate it, you will get a value of 6. So the coordinates of point A were P and Q, and the value for P and Q are actually 3 and 6 respectively. So the question number 6 ends over here. I hope this was clear. It was a quite lengthy maths. Let's move to question number 7. Figure 2 shows a right circular cylinder cut from a solid sphere of radius 4 centimeters. The height of the cylinder is 2h centimeter. The volume of the cylinder is v centimeter cube. Show that v is equals to 32 pi h minus 2 pi h cube. So the volume, the actual formula for the volume of a cylinder is actually pi r square h. But we can see that the expression for the volume that we need to show in our part A doesn't contain a value, doesn't contain r or radius inside the equation. So we now need to find the value for r in terms of h. So let's zoom in on the diagram. We know that this is the radius of the cylinder, and as this is the radius, but from this position it is quite hard to find the radius of the cylinder, so I will just draw the radius from this point. These are exactly the two same lines, just few centimeters below, and we can see up to this height, this is exactly the half height of the entire cylinder. As it is just the half height of the entire cylinder, as the total height was 2h, the half height would be just h. And the radius of the circle is given 4, so we can use the Pythagoras theorem, because here it makes a 90 degree, to find the value for r. So the value for r would be something like r square is equals to 4 square negative h square. If you simplify it further, that would be r square 16 minus h square. So the value for r is already here, and now we can write the formula for volume. The formula for volume of a right circular cylinder was pi r square h. I am using the value for r square in this equation, so that would be 16 minus h square into 2h. The value for the height of the entire cylinder was 2h, so it would be 16 pi h minus 2 pi h cube. So this is the value for the volume of the cylinder. Sorry, not 16. 2 into 16 is actually 32. So 32 pi h minus 2 pi h cube. So this is the value for the volume, and this is the equation that our question asked us to show. So part A is done, and we have to write as shown in this space. Part A is done. Moving to part B. Using calculus, find the stationary value to three significant figures of V. Show you're working clearly. So we need, as the question have asked, to find this use calculus. So that means we need to differentiate the equation for V. That is dV by dH. We are differentiating the equation for the volume, and if we differentiate it, the equation would be 32 pi minus 6 pi h square. And as we need to find the value for V when for its stationary, we know at stationary point dy by dx is always equals to 0. So we can write these equations as equals to 0. and if we take h the common, that would be 32. Sorry, if we take h the subject, that would be 32 pi by 6 pi root over, and if you simplify it, the value for h comes up to be 4 divided by root 3. 4 divided by root 3 is the value for h, but we do not need to find the value for h. We need to find the value for volume with this h. The value for volume with this h would be v is equals to 32 pi, the value for h was 4 by root 3, minus 2 pi 4 by root 3 cube. This was the equation, and if you simplify it, you will get a value of 154.7775 centimeter cube. But as our equation asked us to find the value of v to 3 significant figures, we need to round this up to 3 significant figures. That would be 155 centimeters cube. So the value for B volume is done. So part B is done. Moving to part C. Find and estimate to one decimal place of each of the two values of h for which the volume of the cylinder is 100 centimeters cube. So we need to find the value for h when the V was 100 centimeters cube. And as it says an estimation, we don't need to do any calculations. We just need to use the graph for this. The graph is already drawn. We can see that here this is the value for V is equals to 100. We need to find the point where this line corresponds or meets with the curve. We can see that this meets at around this area. And now I'm going to draw a vertical line to find the point where it comes on the x-axis. And that is basically 1.05. So 1.05, and the other point would be, if we extrapolate this line, it rounds to be in this area, and the y value for x-axis for this point is 3.35. Now our question asks to give the value to one decimal place. So if you round up 1.05 to one decimal place, it is actually 1.1. And if you round up 3.35 to one decimal place, this is 3.4. And therefore the value for height when v is equals to 100 is 1.1 centimeter and 3.4 centimeters. I hope question number 7 was clear. Moving to question number 8. Figure 3 shows the plan of a floor ABCDEF in which all the corners are right angles and CD is equals to x meters, AF is equals to y meters, the length of DE is twice the length of CD. This is given that the length of DE is twice the length of CD. Let's write the lengths of each side in this corner. CD is x and AF is y. DE is twice the length of CD, that means 2x, and AF is twice the length of AF, so FE is 2y. Now we need to find the length of CB and AB. We can see that the entire horizontal line or base of this floor plan is FE and the half horizontal base is CD. So in order to find the length of AB, we can subtract CD from FE. So AB is FE minus CD, that is 2y minus x. We can do the same thing to find the length of CB, that is this entire horizontal height of the floor plan is DE and the other horizontal height is AF. So in order to find the value for CB, we can subtract AF from DE. So DE minus AF, that is DE was 2x minus y. So this is the value for CB. Now, the question has already given us the information that the perimeter of the floor plan is 68 meters and we need to find an equation in terms of x. So we can use this formula for perimeter because the value for perimeter is already given. We know the formula for perimeter of any object is sum of all its sides. So here the perimeter is 68 and now we need to add all the sides, that is AB plus CB plus CD plus FE plus AF plus DE. So these are the 6 sides that we need to add together and we will get a value of 68. And let's write the expressions for each length. The value for AB, the expression for AB was 2y minus x, CB was 2x minus y, CD was 2x, FE was 2y, AF was x, DE was y, and equals to 68. We can see that this y cancelled out with this y, this x cancelled out with this x. So we are left with 2y, 2y, so 2 plus 2 is 4y, and 4x, 4x plus 4x is equals to 68. If we take 4 common, we have 4 x plus y is equals to 68. Moving the 4 to the right hand side, that would be, it would be divided with 68. So x plus y is 68 divided by 4 and the equation is x plus y is equals to 17. So the equation is done and part A is complete. The area of the floor plan is 248 meters square. Show that 2y square plus 2x square minus xy is equals to 248. So now we need to find an expression for the area of the floor plan. Let's draw a diagram first. Yes, and now as we can see that this is exactly not a regular shape. It's not a square, not a triangle. So to find the area, we need to draw another point over here. Let's imagine that there is this point x. Let's imagine this point as x and label all the other points. That is A, B, C, D, E, and F. So we can see that now it actually looks like a much simpler diagram. Like we can see FEDX as a bigger rectangle and ABCX as a small rectangle. And in order to find the area of the floor plan, we can easily subtract the area of the small rectangle from the bigger rectangle. So let's start drawing it. Let me first write it down over here. Big rectangle is actually XDEF and small rectangle is actually ABCX. So these are the two rectangles, and in order to find the area of these two, at first we find the area of XDEF, the area of the rectangle XDEF, and we can find it by using the length of FE and DE, because these are the two lengths that covers the entire area or entire height. So FE into DE, the area of FE, the length of FE was 2x into 2y, and therefore the area of the bigger rectangle is 4xy. We can now find the area of small rectangle, that is ABCX, by using the length of AB and the length of CB. So CB into AB, the length of CB is actually 2y minus x and 2x minus y, If we multiply 2x into 2y, that is 4xy minus 2y square minus 2x square and plus xy. And if we simplify it, we get a value of 5xy minus 2y square minus 2x square. And now the area of the floor plan. We can find it by subtracting the area of the small rectangle from the area of the big rectangle. So x DEF minus ABCX. The area of the big rectangle was 4xy and the area of the small rectangle was 5xy negative 2y square negative 2x square, and we already know this would eventually be equals to 248, so we can write 248 over here. 248. So if we simplify it, then this would look like 5xy positive 2y square positive 2x square is equals to 248. If we further simplify it, we see that it's 4xy and 5xy negative, so it would be 2y square positive 2x square and negative xy is equals to 248. Now this was the equation that the question asked you to show, and it's already done. So we can write as shown over here in brackets. Part B is already done. Moving to part C. Find the possible lengths of AB show clear algebraic working. So we need to find the length of the AB, and in order to find the length of the AB, we need to find the value of x and y. And we can find it by using the simultaneous equations, because we have two equations already. This is equation 2 and this was equation 1. This was equation 1. So let's use these two equations to find the value of x and y. Let's move to other page. So the two equations were 2y square 2x square negative xy is equals to 248, equation 2, and we are just rearranging the equation 1. That is, the equation 1 was x plus y is equals to 17, and I am making x a subject. That would be 17 minus y, and let's name it as equation 3. Now I am substituting equation 3 into 2. So I am substituting equation 3 into 2, and we will get 2y square plus 2x square is going to be 17 minus y, and this x would be again 17, this would be a whole square, and 17 minus x into x is equals to 248. If you simplify it, you will get a value of 2y square positive 289. Let me just first break this square. 17 square is actually 289. That's gonna be 2 into 17 is 34, negative 34y and positive y square, and this is going to be 17y positive y square is equals to 248, and this part would be 2y square. Now I'm multiplying the 2 with the things inside the bracket. So 2 into 289, 289 into 2 is actually 578, 578. 2 into 34 is 68, 68y, and 2y square minus 17y plus y square is equals to 248. If you simplify it, you will get a value of 4y square and 17, sorry, not 4, there's another y square at the end, so it's 5y square, 5y square and negative 85y we have two numbers, this 578 and the 248 on the right hand side. If we take the 248 from the right hand side to the left hand side, it becomes negative, and if we subtract 248 from 578, you will get a value of 330, positive 330. So that would be positive 330 is equals to 0. We can take 5 common, and that would be y square negative 17y positive 66 is equals to 0. And if we shift the 5 to the right hand side, it would be divided by 0, and anything divided by 0 is 0 itself. So the equation now looks like y square negative 17y positive 66 is equals to 0. And now we need to factorize it. Now I'm going to split the negative 17 into 2. I will split it by 6y and 11y plus 66 is equals to 0. If we take y common, it would be y negative 6, and 11 common, it would be y negative 6 is equals to 0. And the equation is y negative 11, y negative 6 is equals to 0. So the two values of y are y is equals to 6 and y is equals to 11. So these are the two values of y. Now we need to find the two values of x for the two values of y. So substituting the values of y into equation 3. Equation 3 was x is equals to 17 minus y. So when y is equals to 6, x would be equals to 17 minus y, and the value for y is 6, so it would be 11. And when y is equals to 11, x would be 17 minus 11, that would be 6. So these are the two values of x for the two values of y. And now we need to find the two lengths of AB. So lengths of AB, the equation for AB was 2y minus x. So AB was 2y minus x. Let's choose the y is equals to 6 and 11 first. So it would be 2, 6 minus 11. This gives a value for 1 meters. And the other value for AB would be 2, 11 minus 6, and this is 16 meters. So these are the two values of x, 1 meter and 16 meters. So actually the entire question 8 is done, and this was the end. I hope this was clear. Moving to the next question, question number 9. The transformation with matrix A is equivalent to the transformation with matrix B, followed by the transformation with matrix C, where C is a 2 into 2 matrix. So let us first imagine that the matrix for C is A, B, C, D. So now we are imagining, okay, this is not the actual value. We are imagining the value for C to be A, B, C, and D. And why am I exactly imagining this? Because the question has provided that the matrix for the original value of the matrix C was a 2 into 2 matrix. It means 2 rows and 2 columns. And that's why I have imagined my value of C to be A, B, C, D, because it has 2 rows and 2 columns. Let's continue. Now an equation will form. And what would be the equation? The equation would be A equals to the product of matrix B and C. A equals to the product of B and C. So we can imagine that the equation would be something like A equals to B into C. So now let's put in the values of each matrix inside the equation. Now matrix for A is 3, 4, negative 1 and 2. And the matrix for C is A, B, C, D. And B is 3, negative 1, 2, negative 2. Now let's multiply the two matrices of B and C. We are using the method first row, first column. So 3 first row and first column means 3A plus 2b, first row second column means negative a negative 2b, second row first column is 3c plus 2d, second row third column is negative c negative 2d. Now we can use the comparing the coefficients to form four equations. So at first I am gonna form an equation using 3a plus 2b is equals to 3. So 3a plus 2b is equals to 3. This is equation number 1. And let's form an equation using this two, that is negative a negative 2b is equals to 4. Now I am not gonna stop over here. I will make a the subject of this second equation. So if we make a the subject, it would be negative 4 negative 2b. So let's see that this is equation number 2. And we can substitute equation 2 into 1. So if we substitute equation 2 into 1, the thing would look like a negative 3 negative 4 negative 2b plus 2b is equals to 3. And if you multiply this, you will get a value of negative 12 negative 6b positive 2b is equals to 3. And negative 6b positive 2b is negative 4. So negative 12 negative 4b is equals to 3. Moving the 4b to the making 4b the subject, it would look like 4b is equals to negative 15. And if you make b the subject, it would be negative 15 over 4. So the value for b is already here, and now we can use it to find the value for a. So we will now substitute b is equals to negative 15 by 4 into equation 2. So that would be a is equals to negative 4 negative 2 negative 15 by 4. And if you calculate it, negative 4 negative 2 negative 15 by 4, you will get a value of positive 7 by 2. So the value for a is positive 7 by 2. Now I am going to make another two equations using this value, sorry, not this actually, third and third value of this. So the equation would be 3c plus 2d is equals to negative 1. This is equation number 3. And negative 6 negative 2d is equals to 2. Now I'm going to make c the subject of this, and it would be negative 2 negative 2d is equals to 4. This is equation number 4. And now I can substitute equation 4 into equation 3. So let's move to the other page because it's quite clumsier over here. So moving to the other page, the two equations that I formed was 3c 2d is equals to negative 1. This is equation 3, and the other two equations was c negative 2 negative 2d is 4, equation number 4. And substituting equation 4 into 3 negative 2 negative 2d plus 2d is equals to negative 1. If you multiply this, it will be negative 6 negative 60 positive 2d is equals to 1, and it would be negative 6 negative 4d is equals to 1. And if you make 4d the subject, it would be negative 5. And the value for d would be negative 5 by 4. So the value for d is now here. We can find the value for c using this. So substituting, d is equals to negative 5 by 4 into equation 3. Sorry, equation 4 actually. So equation 4, if you substitute this value into equation 4, it would be c is equals to negative 2 negative 5 by 4. If you calculate it using a calculator, you will get a value of negative negative 2, negative 2, negative 5 by 4. The value is half, positive half. The value is half, positive half. Now we have the value for everything. A, B, C, D. We can just now find the matrix C. So C is the value for A was 7 by 2. The value for B was negative 15 by 4. The value for C is half. The value for D is negative 5 by 4. Now we can take negative 1 by 4 common, and that would be negative, that would make the inside of the bracket, things would be negative 15, negative 14, 15, negative 1, and this would be positive 5. Positive 5. So this is the value for, this actually would be 2. I did a miscalculation, so this would be negative 2. Negative 14, 15, 5, negative 2. So this is the value for matrix C. I hope question number 9 was clear. Moving to question number 10. Triangle ABC has sides AB 10 centimeters, BC 7 centimeters, CA 6 centimeters. Calculate the area to 3 significant figures of triangle ABC. In order to find the area of the triangle ABC, at first I need an angle of any side. So I will find the angle of this side using the cosine rule because all the sides are given. So angle ACB would be cos inverse, as 10 is the opposite of that angle. So the thing would be 6 square plus 7 square negative 10 square divided by 2 into 6 into 7, and this thing, if you calculate it, you will get a value of 100 degrees. So the value for the angle ACB is 100 degrees, and using this we can find the value for the area of triangle ABC. So area of triangle ABC is half into A into B into sine theta. Here the value of A and B were 6 and 7 respectively, and theta was 100 degrees. So 1 by 2 into 6 into 7 into sine 100 degrees. And if you calculate it, you will get a value of 20.7 centimeters square. Correct to 3 significant figures. I have put my answer to 3 significant figures because the question asked me to do so, and this is the value for the area of the triangle ABC and the end of part A. Moving to part B, figure 4 shows triangle ABC and a circle inside the triangle so that each side of the triangle is a tangent to the circle. Calculate the radius in centimeter to two significant figures of the area of the circle. So now we need to find the radius of this circle. So at first I will divide the circle. I will divide the triangle into 3 smaller triangles, and I will divide the triangles in such a way that every triangle's height would be the radius of the circle. So I'm connecting this circle center with the C, connecting this center with A, and connecting the other center with B. We can see that the height that all these 3 triangles is actually a part of the bigger triangle ABC, and therefore the area of the sum of the area of these 3 triangles would actually be equals to 20.7. That was actually the area of the bigger triangle ABC. And we can see, let me draw it using another pen. We can see that this is the height of this triangle. The height of this triangle is this, and the height of other triangle is this. We can see that these are the height. These yellow lines are the height of the triangles, and these yellow lines are also the radius of the circle. So we can see that all the heights are the radius of the circle. Now let me name the point center as 0, and now Moving to the next page, we can find the radius using the area of these three triangles. So at first, area of AOC, AOB and COB. AOC, A triangle AOB plus triangle COB is equals to 20.7, and the area of AOC would be half into radius into 6. So it would be half into radius into 6 plus the area of triangle AOB would be half into radius into 10, half into radius into 10, and the area of COB would obviously be half into R into 7 is equals to 20.7. And if you simplify it, you will get a value of 3R, 5R and 3.5R equals to 20.7. If you add all this, you will get a value of 11.5R is equals to 20.7. If you make R the subject, it would be 20.7 divided by 11.5. Therefore, the value of R is 1.8 meters. So the value of R, radius of the circle, is 1.8 centimeters, not meters, centimeters. I hope question number 10B is clear, and that is the end of question number 10. Moving to question number 11. Find the range of values of x for which both 2x plus 3 bracket 4 minus 3x less than 8x and 6x minus 5 less than equals to 2x minus 3 whole square. Show clearly algebraic working. So we need to find a range that is applicable for both the inequalities. So let's solve the first inequality. That is 2x plus 3, 4 minus 3x less than 8x. That is 2x plus 12 minus 9x less than 8x. So if we take all the x's to the right hand side, it would be 12 less than 8x positive 9x negative 2x, and that is actually 15. So inverting the equation would look like 15x greater than 12. If we make x the subject, it would be 12 by 15. And if you simplify it, it will be 4 and 5. So the range of x for this equation is greater than 4 by 5. 4 by 5 is actually 0.8. Let me write over here 0.8. Use a bracket actually, 0.8. And now I'm going to solve the other equation, that is 6x minus 5 less than equals to 2x minus 3 whole square. 6x minus 5 less than equals to, if we break the whole square thing, it would be 4x square negative 4 into 2 6, 6 into 4 is 24, so 24x positive 9. And if we take everything to the right hand side, it would be 0 on the left, and 4x square 24x, it was 24x, let me draw it again, write it again, 24x plus 9, and 24x minus 6x is actually 24x negative and minus 6x. Minus 6 is 18, is negative 18x. And now we have negative 9 and 9, so it would be, sorry, I made a mistake actually. That would be negative 24 and negative 6. Negative 24 and negative 6 is actually 30x, and negative 5 and negative 9, we have 9 in positive and negative 5, so it would be 4, positive 4. Sorry, I made a mistake while doing the breaking the square. It would be actually 12x, and this here would be a positive 9. Yes, and then we will continue 0 Everything to the right hand side would be 4x square. This negative 12 and negative 6 would be negative 18x, and positive 14. If we take everything, invert the equation, that would be 4x square, negative 18x, positive 14, greater than equals to 0. And if we take 4 common, let's take 2 common. If you take 2 common, it would be 2x square, negative 9x, positive 7, greater than equals to 0. And then the equation is 2x square, negative 9x, positive 7, greater than equals to 0. And we need to factorize it first. Now, so splitting the 9x into negative 2x, negative 7x, plus 7, greater than equals to 0. And if we take 2x common, so it would be x minus 1 minus 7, so x minus 1 greater than equals to 0. So it would be 2x minus 7 and x minus 1 greater than equals to 0. And then the value of x would be greater than equals to 1, and the other value would be greater than equals to positive 7 by 2, that is basically 3.5. Now we need to find an inequality, or a range of x that is applicable for both the inequalities. So let's draw a scale first, number line first. Let this be the number line and this point be 0. Let's this point actually be 0. This is 0 and this is 1 and this is 2, 3, this is, let's say this is 3.5. Now the value for x is first greater than 0.8, so 0.8 somewhere at around this area. So here it would be a empty circle and the arrow would go towards the right. The other range is greater than equals to 1, so there will be a filled up circle and a value to an arrow towards right. The other value would be a filled up circle on 3.5 and an arrow towards right. So the range that is actually not common would be this, and after this point the range are actually all common from this area. So the range here would be 4 by 5 less than x less than equals to 1, and the other range would be x greater than 7 by 2. So this is the answer of question number 11. I hope question number 11 was clear. Moving to the question number 12. A company produces bird food made with sunflower seeds, corn, and millet. The weights of sunflower seeds, corn, and millet in each bag of the bird food are in the ratios. Sunflower seeds is to corn is to millet is equal to 8 is to 3 is to 1. The total weight of the bird food in each bag is 30 kg. Calculate the weight in kg of the corn in each bag of the bird food. So we need to find the weight of the corn that is used in the bird food. So let's do this. At first we need to find the sum of the ratio. So sum of the ratios is actually 8 plus 3 plus 1, that is 12. So the sum of the ratio is 12, and in order to find the weight of corn, we need to divide the sum of the ratio with the ratio of corn, that was 3 divided by 12, and into the total weight of the bird food, that was 30 kg. And if you calculate it, simplify it, you will get a value of 7.5 kg. So the weight of corn used in the bird food was 7.5 kg. Part A is done. Moving to part B. Tom buys bags of the bird food from a company and sells them in his shop. He sells each bag for $15.04. He makes a profit of 17.5% on each bag he sells. Calculate in dollar how much Tom pays the company for each bag of the bird food he buys. So we need to now find the cost price. So here the selling price is given and the amount of percentage of profit is also given. Profit percentage is also given. So we know that the profit actually is a part of the profit is actually a part of the cost price. The profit is actually a part of the selling price. Like the equation for the cost price would be 100 divided by 107.17.5 into 15.04. We wrote 117 because the entire selling price was actually sum of the cost price and the profit. So that's why we wrote 117.5 as the selling price because it was the sum of profit and cost price, and 100 on the top because it represents the cost price. And if you simplify it, you will get a value of 12.8. So 12.8 is the amount that Tom had to pay to buy each bag of bird food. Part B is done. Moving to part C, the bags are filled with the bird food at a rate of 53 grams per second. Calculate the number of bags of the bird food that are filled completely in 6 hours. So at first we need to convert the 6 hours into seconds. So here, part C, we know 6 hours would be equal to 6 into 60 into 60. That is basically 21600 seconds. 21600 seconds. So these are the number of seconds in 6 hours, and now we need to find the number of bags that are filled, the weight of bags that are filled in this 21600 seconds. Let's convert the 530 grams into kg. If we convert this into kg, that is divide 530 by 1000, it would be 0.53 kg. And now in the question it was already given that in 1 second the machine filled 0.53 kg of the bird food. So in 21600 second, how much of a bag would be weighted or would be filled up? So that would be 0.53 by 21600 into 1. Sorry, I made a mistake. 0.53 divided by 1 into 21600, and if you calculate it, you will get a value of 11448 kg. So this is the amount of the weight that is filled up in 21600 seconds. So that is the weight, but we now need to find the number of bags filled. We know that one bag weighs 30 kg. So 30 kg is the weight of one bag. That means that 11448 kg must be the weight of 1 divided by 30 into 11448. So this is actually 381.6 bags. And as it's a kind of fraction of bags, 381.6, this is not actually possible in real life, so we will round this up to 381 bags. So in 6 hours it fills up 381 bags completely. Now part D, sunflower seeds cost pound 150.75 for 30 kg from farmer A. Sunflower seeds cost pound 162.35 for 25 kg from farmer B. Using an exchange rate of 1 pound is equals to $1.315, find which of the two farmers A or B sells sunflower seeds at a cheaper rate per kilogram. You must show a reason for your answer. Okay, so now we need to find that which farmer sells the sunflower seeds at a cheaper rate. At first we need to find the price for 1 kg of sunflower seeds from each farmer. Let's convert the price for 30 kg from farmer A to dollar. So using the unitary method, we know 1 pound is equals to $1.315. So pound 150.75 must be equal to 1.315 divided by 1 into 150.75, and if you calculate it or simplify it, you will get a value of $198.28625. So this is the amount that the Tom needs to pay to buy 30 kg of sunflower seeds from farmer A. So let's find the price of 1 kg of sunflower seeds from farmer A. So he sells 30 kg for $198.28625. We need to find the price of 1 kg. That would be 198.28625 divided by 30 into 1, and the price for 1 kg of sunflower seeds from farmer A is 6.61. So this is the price Tom needs to pay to farmer A for 1 kg of sunflower seeds. Now let's find the price for farmer B, farmer A, and now we are solving for farmer B. Here the price for farmer B was he sells 25 kg of sunflower seeds at a rate of $1.162.35. So 1 kg must be 162.35 divided by 25 into 1, and the cost for the sunflower seeds of 1 kg of sunflower seeds from farmer B is 6.49. We can see clearly that farmer A sells at a higher price than farmer B. So farmer B sells sunflower seeds at a cheaper cost. Now this was the end of question number 12 and also the end of the entire paper. I hope the video was clear to make you understand all the questions you had while solving this paper. And if you still have any questions, please comment it in the comment section. I would really like to answer your questions, and please hit the subscribe button. Thank you for watching.